This slideshow concerns the use of statistics in the neighborhoods network. Content in this slideshow. Why use statistics? 2. What's random sampling? 3. Determining sample sizes. And 4. That means how to use the sample size table. And finally, 5. A caution about randomness. Why use statistics? 1. Neighborhoods need to exchange information and collaborate with other neighborhoods. 2. In virtually every election district pertinent to governance, there will eventually be a huge number of NGUs. 3. Intelligent application of statistical techniques on each governance issue permits us to communicate with a reasonable number of neighborhoods to perform our necessary work. Why use statistics? Continue. 4. On each issue, we can find a small number of neighborhoods to poll or collaborate with because the number of viewpoints on any given issue is likely to be small, let's say 2 or 3 or so. 5. That means on any given issue, if we pick say, 6 or so neighborhoods for collaboration at random, we are likely to encounter all or most views of the issue in the relevant general population. 6. And where we need very reliable data on how a relevant population feels about a potential solution to a problem in a proposed policy for government to implement, a few hundred or a few thousand neighborhoods to poll will be sufficient. Random sampling. Random sampling means we pick, that is, choose or select, from a multitude of entities, usually NGUs in our application, without bias. The technique is actually quite simple. First, you enumerate the entities you want to sample. For example, 1, 2, 3 up to, say, 86. This enumeration is called a range. Then you tell a computer program there's one at random.org in the range. Well, in this case, it's 1 to 86, and it will give you a sample. And if, say, you ask 2 times, you might get 31 and 5, which the program came up with by doing its random sampling technique. Then, the samples you use are the ones enumerated as 5 and 31. And that could be 5 and 31 could be the indexes of NGUs listed in some register, for example. But how do you know how many samples they ask for? The sample size depends on what you're trying to do. Secondly, if you want a small number of neighborhoods to collaborate with on forming a solution to a problem or establishing a policy directive, you'd like to keep the number small, but large enough to make it likely all viewpoints are present. But if you want the sample size sufficient to ensure you will get a very accurate statistic on the acceptance of a policy mandate to be delivered to government, then you need to use a statistical table indicating what sample size you need. To discuss this further, we need to indicate some statistical terms. Population size, which is the numerical size of the population you'd like to measure for some characteristic. That is the number of NGUs, the number of people, or the number of whatever. Another term, accuracy. What's meant by this in statistics? The percentage accuracy you'd like to achieve by doing your statistical measurement of some characteristic of the population. Another term, confidence level. If you were to repeat the statistical survey you intend to do, if you were to do it a huge number of times, this would be percentage of those times that you would actually get an accuracy that you've indicated. Given that, let's go on. This is a sample size table, and on this slide, I'm simply going to indicate that way on the left, where it says pop size, there's a column there that gives some possible population sizes, the number of NUs, and so forth, 50,000, 10,000, million. Next to that, just to the right of it, there's a block called the confidence level equals 80%. We'll talk about it on the following slides. And then to the right of that, over to the right of this table, we have a block on the top of which is confidence level equals 99%. So what's in this table? As we've mentioned, there are 3 blocks or region in the table. The population size column on the left lists some population sizes. The region just to the right in the table, where at the top of that region it says confidence level equals 80%, this block gives the number of samples you need to collect to obtain the accuracy indicated for the entries in the leftmost column, the size of the population, but with only an 80% confidence level. And for the block to the right, where at the top it says confidence level equals 99%, is similar to the 80% block, but contains sample sizes for a much higher confidence level. So how to use this table? 1. Choose the confidence level. This is the percentage of the time that you do this kind of statistical poll that you are likely to get the accuracy you have indicated. And that confidence level will be 80% or 99%. 2. Choose the percent accuracy you expect from this poll. And you'll see the columns for 20%, 10%, 5%, and 2%. And 3, choose the size of the population you want to investigate with your poll. And those are listed to the column to the left. How to use the table continued. For example, If you wanted to collaborate with a local group of 45 neighborhoods and want a statistical accuracy of only 20%, and you want it to be really at 20%, at least 80% of the time you do this, then you should use a sample size of 9 neighborhoods. Or, for another example, if you need to check the acceptance with a high confidence level of a mature candidate policy mandate with the population of an entire country, then you would choose the 99% confidence level block, the 2% accuracy column in that block, and you would go to the bottom of the table where the population size is 1 million and up in that row, you would see 4,130 samples are needed to do that kind of survey. A caution: statistics can be tricky. We can easily make mistakes. For example, suppose we get 20 random samples from each of the 50 United States states and wanted 1,000 samples for the entire country. You might think that these 20 samples from each state can be collected together to make the 1,000 samples, but that's not true. The samples from states with small and non-typical populations would not be true random samples for the entire country. You gotta be careful. The main idea is that to find public opinion, determine how many neighborhoods you need to collaborate with, or to test candidate policy issues, you don't need to talk to the entire population. You can select a random and reasonably small number of neighborhoods or people to be in communication with. Well, this is the last slide of the presentation, but I want to note you can also examine, number one, the book, The Neighborhood Network by Robert Mayer, and a hard copy is available at lulu.com, the publisher. In that, there's a good chapter on statistics. And two, if you don't need a hard copy, you can go to the website, www.theneighborhoodsnetwork.org, and on the red page, the first page, on the left, is a little icon of the book, which if you click on it, you can download a PDF copy of the book. Anyway, end of this slideshow.